This is Advanced Algebra 1.1. We're going to look at examples 8 and 9, and this is going to be solving an inequality. And both of these are compound inequalities. The first one's an and statement, so in order to find our solutions, it has to satisfy both ends of this. So we have x in the middle, and this is what we want to get x all by itself. So we're going to focus on the middle, but it's also going to apply to the outside parts. So the first thing we're going to undo is the plus 5. So we'll subtract 5, but we also subtracted out on the 2 outside parts. So there's really 3 places where we subtract 5. So a negative 15 still less than 3x, which is less than or equal to 3. Then to get x by itself, we'll divide each term, each part here by 3. So I have a negative 5 is still less than x, which is less than or equal to 1. If I was to divide or multiply by a negative, that's when I would switch the direction of the signs. But I still have those less than symbols. The other thing to note here is that these arrows are pointing to the smaller numbers. So negative 5 is the smallest. If it does not point in that direction, you will not have a solution. So we need to make sure we have those 2 values on our number line. So we're going to have a negative 5 down here and a 1 up here. The negative 5 will have an open circle. The 1 will have a closed circle. And this is saying that x is in between. So it has to be greater than negative 5, but it has to be also less than 1. Now in example 9, we have an or statement. So we're really going to solve this as 2 separate pieces, unlike example 8. So in the first one, I'm going to add 1 to both sides. And then I'm going to divide by 2. So x is less than 6, or equal to. I could graph this right away here. So I'm going to put 6 on my number line. It is a closed circle. I'll put 3 on my number line. I didn't divide this here. So I have to have 3 on my number line, closed circle, and I'm going to go less than that. So all those numbers will be included no matter what I'm doing with the second part. Well, the second part, I'm going to subtract 3 from both sides. And then divide by 4. So 1 is lower than 3, so I need to put that down here. And again, it's a closed circle. They could be different. And this one's going up. Now with an or statement, you do have to highlight everything that it does talk about here because only one of them has to be true at a time. Both of them could also be true. But what happens here with the solution, it highlights the whole line. And so, in summary for this, our solution will be all real numbers. All those numbers on that line. So it is possible with the or statements to have an answer where every single number is included. If you have the and statement, like in example 8, it's possible to have no solutions because there's no, particularly like when those arrows are not pointing to the smallest number, it won't satisfy both parts of that compound. So those are ones to really be careful with. That true or statement, like example 9, if it was a true or one, we'd have 2 parts going opposite directions. And something that is an and statement, it typically, when it's in our true fashion here, it will be going inwards and it will be the numbers in between 2.